Hello and welcome to XP Solutions webinar. So today we're doing something a little bit different. We've got a bit of a case study that we're running with one of our clients, Logan City Council. So we've got them to come in and share a bit of their experiences on 2D modelling inside their design office. So we've welcomed Liam Callaghan here, who's sitting with me.
G'day.
And he's going to share about how they've innovated on some of their processes and their tools within council to save council $500,000 about that in a short period of time and achieve some better stormwater outcomes for the residents of Logan. It's part of their master drainage program. So I thought we'd just jump into a little bit about XP and who we are. So we're primarily a water modelling software company. We produce tools with engines and with graphical user interfaces that are easy to use to be able to model, the engineering world. So within a council, you could use it for a design, sort of process planning, process of floods, development assessment processes, and within consultants, the similar type of thing. So our products we're talking about today, specifically, Logan, you've got XP Storm and XP2D.
Yeah.
We'll demo in XP Swim today. Fundamentally the same product, just a different name. And we've also got XP Rafts there as well, which we're going to be talking a little bit about the hydrology changes in rational method that they've adopted at Logan. So XP Rafts would be one of those tools that you can use instead of using the rational method. So I'm the sales engineer here at XP, Liam's senior design engineer. I just thought I'd sort of kick off by saying, thanks for coming in.
No worries.
And so what, you've been using XP for?
Yeah, I think we bought it in about October 2014, and we kicked off. It was a little bit slow, a bit of a learning curve, but I think the visual interface just makes it quite easy to get a bit more comfortable with what you're seeing as results and validating making sure the inputs look like what you expect from what we used to do with 1D and still do with 1D and rational method. But good comparison tool, good scoping tool, and we're using it for design now.
Okay, very good. Yeah, so I guess this webinar came about because we heard, you guys called us two days before a conference and said, oh, we're doing a paper on XP.
Yeah, surprise.
You might want to come in. And we're like, oh, okay, that's all right. Didn't really know about it. So we sat into the presentation at the Stormwater National Conference, and we thought, hey, this would actually be pretty good to teach other people in a big webinar. So I guess we'll kick off, and we'll start with a poll for everyone. So what we'll do is we'll bring up this poll on the screen, just because we're trying to get a bit of a gauge of the audience about how comfortable you are currently with using 2D model results in an urban detailed design. So just give us a couple of seconds and we'll launch that poll. So these answers are anonymous, so feel free to vote however you would like. We're not going to present any results to anyone, and we won't know who's actually voted. So I guess while we're waiting to do that, what's been your sort of number one thing you think has been improved with using XP over what you used to do at Logan?
I have to say, with the most value we've found it in is doing pre-designed scoping, kind of like prelim designs with XP. So previously we'd get a scoping document and launch straight into design, but now we get the chance to get a better idea of what the existing problem is, if there is a problem, and see what it'll take to actually fix a stormwater issue, and then we can go back and check the cost of that. So we'll know before we start designing whether it's worth it and whether it'll hit the budget, and if we have to ask for more money before we do design. That's the biggest benefit I think we've found so far.
Sure. So you can just do that analysis beforehand.
Yeah, that's good. Right.
All right, so we've had, most people voted now, so we'll close that one off and share the results to everyone. So it looks like we've got, most people are somewhat comfortable with using the 2D, but we've got, I'd say, the same number of people who are not really sure or not comfortable at all, and some very good 2D modelers in the room as well. So very good. I guess I'll leave it up to you to talk about Logan.
No worries. Liam? That poll reminds me of the the polls that happened during the test, like who thinks Australia's going to win, and that's pretty relevant today. We got a test here, cricket test that is. Anyway, I digress. So Logan City Council, it borders, it's just south of Brisbane City Council, to the south of Brisbane, Redlands, I believe, Scenic Rim Council and Gold Coast to south, and we're not as big as Brisbane, but we're growing pretty fast. There's quite a large growth. Most of the growth happened. I've got some slides after this showing some images. A lot of growth in the 60s and 70s. A lot of it was fueled by the housing commissions. A lot of it was housing commission houses. As rapid growth. A lot of it was fueled by the Southeast Freeway going through, and the stormwater infrastructure really struggled in regards to putting in a lot of houses really quick and it not being a really great level of stormwater infrastructure. So that's what our master drainage program's for now, fixing a lot of those issues up and bringing it up to a standard that we're happy for in 2016. This is 1955. This is a little bit later. That's 1970, 1977, 1987, 1994, 2002, and that was the last image. So I was only alive for the last 3 images, so I can't really say what happened before, but all we know is the infrastructure standard is not great now. And the master drainage program and a lot of the projects which we'll show you today are based around fixing the issues that were built back then. So our issue is fixing stormwater inundation, not for flooding, but flooding sometimes is a boundary condition for us. And the way that we rank which projects go first is based on cost benefit. So there may be a massive issue, but if it costs too much to fix and there's another project that can benefit people more for a lower price, that's the way they're ranked, most benefit up front. Only issue with that, and I'll just touch quickly on it, is that I recommend if anyone else is looking at this way of ranking projects to not limit it to hitting a certain immunity. So you may achieve massive benefit going to a 2% AEP scheme. You don't need to limit it to a 1 in 100 year event. So I'd recommend that. I'll show you some photos just before I start of Lake Road, pretty aptly named.
Ironic.
Yeah, that's right. It's a photo, probably not even a very high storm event, and it just shows the amount of water through this area. Won't be one of the projects today, unfortunately, but we look to do this in possibly the next couple of years as a job. XP Storm would definitely be used for at least scoping this project up. So the old way that we used to do things before we got XP Storm was with PC Drain. Now we still use this for a detailed design tool because it does some things that XP doesn't do, but relying on it solely, being that it's based on rational method, it can be conservative at times. It's good that because it's got automatic pit losses, but I believe XP is looking into this.
Yeah, I was actually just on a call with a head development team, and you know it's definitely on the important list, big time.
Yeah,
so
I think we should start a petition to get it in because we really want it.
Because you want to use XP, right?
Yeah, we really use it more. It's great. Okay. So why did we implement it? Well, there's a couple of reasons other than the cost savings, and we did save. I think Ben said we've saved about $500,000 in the last year or so. We've probably saved more, as a matter of fact, and that's not even factoring in saved time. So we're scoping projects so fast that we're actually having to send some projects back because we found there is no issues. The scoping happens so quick that we just know that a project's going to cost too much. So just the savings in time alone are not quantified as that in that $500,000. And we know this scoping is quite accurate. And we can try alternative options really quickly. So we shouldn't get to the end of a design, a detailed design, and go and people ask, why didn't you think of this option? Because we may have 4 or 5 options analysed before we get a detailed design. There are a couple of projects that we save money on, and it's been great for justification of projects where we do spend more money. And usually when we do this, the planning, the prelim designs with XP, we can justify why the projects are blown out with the budgets, because you can show where you're taking the water from, where you're putting it underground, how much infrastructure you need to put in to solve an issue. And it's very visual, which I'll show you.
So that's good for the councillor who's sitting at your back.
That's right. Yeah. I mean, I'll show you a video, and we've brought videos of stormwater events, storm events, so we can show where the issues are and why something may be needed, why we need to spend $1 million somewhere.
So it's hard for, typically it would be difficult for a councillor to understand that unless they're an engineer.
That's
so
right.
The visual is,
yeah.
Okay.
Yeah. Exactly. So first project I thought I'd launch into. This job, it's got quite a big upstream catchment. It borders, I guess, urban fringe. So there's quite a lot of forest kind of upstream, but it is a mix of urban and rural and forest. It inundates really frequently. So it's a basic culvert. It's not actually an urban network. But the whole project was actually meant to be a channel rehab. So the reason we've actually done a 2D model is because we wanted to prove whether we were going to cause afflux by filling in a massive scour hole. And we did have legal threats, so it's useful to have this. I'll just jump into the model now. Here we go. So this is it. So you can see in the middle of the screen.
Yep.
There we go. There's the model. So this one has got two 1D hydrologic connections, which we use with Lawrenson method to model those flows. So I'll go to the runoff screen. So you can see that the two active nodes are nodes 11 and node 2. And just to show you, there's the subcatchments broken up into pervious and impervious. I'll just wait for it to catch up. There you go. So that's one, and you can see it's 200 and that one's 185 hectares, quite large. And the other one is about 30 from memory, 21.7. There you go. So they're the inflows really. For this one, I didn't actually put a rainfall layer on because I was more concerned about the flows coming in and not so much the flows locally. Now, what I'll show now is just for people who are, I see about 50% are not very comfortable with urban modelling. So I was going to use this model just to show you what you want to do if you wanted to model in a 2D network in this area. So I'll just model in some nodes. So your nodes are your manholes and your gully pits, and I can see a gully pit just here and just here, and I know this isn't going to happen, but I'm just going to put an outflow into the channel. Big tip, make sure your snaps are on always, I find.
Because it's at the top, you'll just snap. Yeah.
Up the little crosshair button. So I'm going to click connect a pipe through from node 15 to node 16 to node 17 and press escape. So I've set up a little urban drainage network. So I'll start off by...
You might want to turn... Oh, you can see it in the background, but if you turn off the background image, it might help to see it.
Yeah, sure, okay. Good idea.
Some people watch this on big screens. There you go.
So now I like to use the background image to eyeball where the gullies go. You can load in a CAD file or a GIS file to give you some idea of where it might be under the ground. But I don't have any here at the moment. So the way we model, just in regards to the 1D to start off with, is if I just right click on the node and edit data. Oh, I'm still in runoff. There you go, hydraulic. So if I edit the data, it's got nothing there to start off with. So a really quick tip for us is that we like to set the surface elevations, so your spill crest level, by going to Tools, Generate Ground Elevations from 10, and it'll go through, and rather than you typing in the actual elevation, it'll automatically put in all new ground elevations. It's a great little way of doing things rather than manually entering that in yourself.
So you're using that in a 1D capacity, but using like the surface to pull that?
Yeah, that's right. So I've jumped ahead a little bit. I've got the surface already in here.
Yeah,
I will talk about that later, but yeah, it's reading the tin at the surface level. So now that you got the ground elevations, the spill crest, you can calculate the node length. So I've just drawn them in, but it'll be default 10 meters for all the conduits. So if I just go all, you can click select to select the links, but I'll just go on select all, calculate, and you can see the ones that are 10 have now got a real world length. And that's a great way of also filling that all out rather than manually getting the ruler out and putting in the actual length of pipe.
Okay.
So now back into, that's flipped, going into the node. So when we want to model in a gully pit, we like to model it in with a spill crest to 2D. Now, just touching, we like to check before we run the model whether any ponding is on for any of the nodes, because what happens is if there's surcharge, that flow, any bypass from that node will just be lost from the model. And I suppose it's in there because some people like to lose the flow in a specific situation, but I just make sure there's none there. It should either be link spill crest to 2D, link invert to 2D if it's an outlet, or a culvert, possibly sealed. Allowed also, I've just found it this morning, is if flows go over that node or are lost, it's actually stored there until the HGL of the actual drainage line drops to below the surface, and then it will drain. So not accurate way of modelling an actual urban drainage situation. So I'm going to shy away from using allowed from now on in the ponding modes. Now, to actually set your inlet capacity, we used to use 2D inflow capture. We only use that now for modelling in orifice flows for field inlets. We now use inlet capacity. So we've got link spill crest to 2D for a road gully. Clicking on inlet capacity brings you here. Now, if it's an on-grade gully, we go rated by approach flow, and Olivia back at Logan City Council has kindly modelled in all of the, I guess, a summary of the inlet capacity charts. Now, if anyone's familiar with the BCC charts, or we use drain waves a lot in Logan, they've rated by the size of the lintel and also the grade of the road. So where you see a percentage here, it's the road percentage. So if I'll just click on a 1.2 lintel at 0.25 road grade, you can see that the capture is pretty high for the approach flow.
Okay,
well, it's not too bad.
So this is just a template that you just got in there that you've added once, and then you can just use it.
That's right, yeah. This is actually an old template, and someone might be able to see this. We found that there was huge capture rates of 100%. It's because there should be a decimal place in front of all these. Now, we've fixed them up, but that's just a trick. Just be aware of your units. So both these are QMEX. So yeah, that's marked that graph up, but in our new templates, they're all fixed.
Yeah, okay.
Yeah.
So if you need copies of templates for these sorts of things, you can always contact XP. We have a repository here. And obviously, Logan, if they want to share theirs with you, I'm sure you can contact Liam.
Yep, sure. No worries. Sure to help. Right. So that one's set. I'll bring the background image back on. Now, if that was down here and it was in a sag, I'll just turn the aerial on. So we don't have detailed survey for this area, so you can see the LiDAR is quite jagged.
It's catching up.
Yeah, it's coming through now. But it is in a sag, so I would model that one in, going to edit data again. I model the inlet capacity as rated by approach depth, and that means that it's not looking at the approach flow on grade, it's looking at a depth for a sag gully. And again, we've modeled in the sags as a separate item for the, so the x-axis is your flow coming in, and the, say again, the gutter, the flow depth is your x-axis, your y-axis is your captured flow rate. Right. Last thing that I'd like to mention in regards to where you have an outflow, we've found sometimes you can just link your final outlet to link invert, and what that means is it's linking the base of the pipe to the 2D. That works fine, but we've found in a lot of cases we need to actually put in an interface layer. Clicking on outfall is good when you've got a boundary condition, like a set boundary condition like a tidal area, but sometimes when we get outfall and put in a free outfall, it will actually draw all the water out of the pipe regardless of the backwater that you've got in your connecting waterway. So how we like to model now is linking the invert to 2D, no inlet capacity because there is no gully on this one, and drawing in an interface layer. So I'm not sure why I've...
So it's you've just got it deactivated. So just
okay.
yeah. So when it's a square,
Right.
you just press the plus symbol and it will activate your little node.
Yep. Yeah. So I'll select all of them actually, and little button on the right hand side, select all pipes, select all nodes, plus. So I guess that's good for turning pipes on and off when you've got when you're doing options.
Literally turns them off from the engine. Yeah,
exactly.
Cool.
So I've got the interface. So I'll draw an interface between. Just imagine there's a head wall down there. I'm drawing the interface layer, interface line, and
that's to link the 1D to the 2D.
That's correct. Yeah, I'm linking the interface line to the 1D, and this is just putting the 1D flows into the 2D grid. Final point to make about the interface line is that we mostly use SX, and the head interface is usually when you've got a 1D into I believe large grids. SX is when you've got smaller grids than your pipe size or your head wall size. That's the way I understand it, and it seems to always work for us. So I'll leave it with that. The help file is actually quite handy with this. That's how I've learnt that. Right. Now that's the 1D. Now just quickly going into 2D and touching on 2D setup. So in regards to the grid extents, I've got a grid extents already set up for this model. You can see that my point of interest for this one was the overtopping of the road, and what I've done there is I've actually made the grid parallel to the running parallel to the road, and the benefits.
Just updating still.
Yeah, I'll try and go a bit slower. So you can change that by going to properties and type in the orientation angle.
So you can just change the angle of the grid to line up with the road to get what you need.
That's right, yeah. When you've got a big network, it can be hard. It helps when you've got 90-degree roads, but a lot of modern road networks, the roads are all over the place. So in that case, you just want to make the grid as small as possible, as practical, and line up as best as possible where you've got sensitive areas like sags or whatever. The only other thing is we haven't done this yet, but I believe you can do multiple grids.
Yeah, there's a multiple domain option where you could set up as many grids as you like and link them together. That's and of different sizes too. So I believe that's a separate module that Logan isn't using. You don't need to use it. But
no,
it's a handy little tool.
It'd be useful for areas where you do have lots of roads coming at different angles if you find the need. Yeah. So I'll turn that off now. Head boundary is also quite important. So once you've drawn the grid, I'll just turn the grid back on now. Your rainfall area, I don't have a rainfall area here because I've got all my flows coming in via the 1D, but if you want to put rainfall on the entire grid, you can just draw a polygon over the area you want to put rainfall onto. And I'll just draw one just really quickly so you can see what it looks like.
So it's just setting up a giant shower over the top of the giant cloud over the top of you.
That's a big square cloud. And yep, they're all loaded in. So these are all our Logan storm events. And we've actually found, even for this 200 hectare size catchment, we still use about a 60-minute, it seems to be the peak rainfall event for urban drainage in all of our catchments in Logan. I don't think we've gone external to 60-minute events. And it's just from trial and error. 45 won't actually give you a higher peak, we've found. So there you go. That's your rainfall. Last thing is the head boundary. So what XP does is when a grid is modelled, a big wall comes up around the grid, and that can be good because you don't lose flow out of the model, but you need to tell the model when you want the flows to leave. And if I turn on the results, you can actually see the water depth. When it comes over this head wall, the outlet spills out, it hits the head boundary and is lost. You want to set that roughly to the lowest. I actually go to the lowest grid level and drop it by a metre. You don't want to have a waterfall of tens, hundreds of metres. It can cause an instability, but that's how we use it.
We got some results.
Yeah, we got some results up there. I won't get ahead of myself. Before we do that, I'll turn that off and go to the
sizzle before the bang.
God, yeah, I know you're dying to see the results. I didn't want to see it. Land use, you need to put in land use. So usually your background land use in 2D is set to whatever you want it to be set to, and that's under job control and 2D model settings. You can see it just here. We've got default land use is urban yard, and that's just the in the grid. It's mostly urban yard.
Okay.
And you can set all those up under 2D land use settings. And you can see on the left-hand side we've got buildings, urban yards. So I haven't got a model in here, but if I wanted to put a polygon around this building and make it a nice big solid structure for the flows to be caught up on, I draw it in with the polygon tool, and that'll probably worsen the flows actually through the channel. And you can see I was more concerned about the actual channel, so I've modelled in the riprap, the vegetation around the channel, and a bit of concrete base there.
So this can all come in from a GIS package as well, or if you've got an existing 2D model out there that you're using, you can by all means just import it.
Absolutely.
Directly in, so you don't have to click there, draw every building in your model. If you've got a GIS database,
that's right.
Yeah, it comes straight in.
Exactly. So I'll turn off the land use, and I'll also turn off the surface. Cool thing about this is that this is the existing model that we've run. So this is the existing case, and we haven't put anything new in. It's just running what's currently there. But should you want to bring in a design tin, so we've actually modelled the new channel. I'll go back one step. You need to load in your DTM at the start of the job. We do that using DTM Builder. So the way we set up our jobs is that we've got a LiDAR tin, we've got a survey tin, and then we've got any design tins. And the way you bring them in, the LiDAR tin, which is your aerial terrain over a whole grid. In our case, we've got kilometre by kilometre grids. They're brought in with just CSV files, and the DTM Builder is how you bring that in. And this can take 5 minutes per or 10 minutes per kilometre by kilometre grid because they're just so point dense. The DTM Builder is the best way to do that is because it splices together the kilometre by kilometre grid, so there's no gaps between the tins to potentially lose flows down between.
Yeah, another option is you could just have it ready and bring it straight in.
Exactly.
You could reference it or just load it.
Yeah.
But yeah, there's that little builder in there if you want to do something fancy.
Yep. Yeah. That's it. And that's what you see here. That's it's contoured the DTM that we've created earlier. I've got a survey here which we've brought in. Now, our surveys come in as 12 DA files and they've got a tin included. So for this case, I'll bring in the survey.
So that's just come straight in from 12D?
Exactly, yeah. Our surveys will have a 12 DA file. It zooms right out to the extent of the job, so you got to zoom back in. That's good fun. So it comes in as one of our graduates called it a rainbow sea. It's in a help file. I just like to call it I like to change it back to showing the major contours at say 1 metre and 0.2 for your minors, and it brings it back to something a bit more less psychedelic. So that's that. That's your detail survey. Now, I'll do one last thing. I'll bring in a design tin. So a designer's gone through and done all the design strings in 12D, and before he finishes, he gives me a tin. And the tin can be brought in as a 12DA file. So if you try and bring in strings, it won't work. You need to bring in, export the 12D tin as a 12DA file. And I'll just quickly bring in one for that here so you can see what we've done.
So just a point on that, if you're using Civil 3D or Advanced Road Design or any of those other tools, very similar process. There's nothing much different. I guess you just use 12D, so
that's right. Yeah.
You can talk about what you know.
Yeah, that's it. Again, zooms out. I'll zoom back in, and that's the design tin. And if I change it from the Rainbow Sea, it looks like what you'd expect from a new channel construction, nice and neat, base with walls, and that's what we've got. Last thing with the DTM is that you need to set priorities. So the first priority would be your design. The second priority would be your detail survey, and your last one would be the DTM, the LiDAR. The reason for that is that the program XP looks for the first point first, so the first tin first. Can't find it, drops to the next, and then the next. And it's a good way to having multiple tins on your job and filling in the blanks, I guess, where you don't have detail survey. Another thing to really be careful for when you've got LiDAR and detail surveys is that one project we did, we inadvertently created a bathtub. So the LiDAR was actually sitting higher by about 200 mils than the road, just because there was I guess a filtering issue with the LiDAR. So be very careful and just do there's a little button on the right where it's got a section profile. You can profile through any area you want to look at, and just check to see after you run the model whether it looks right. If you're expecting flooding and there's no flooding, there's probably something wrong. Okay, now the results. Now the reason we did this job was just to check out whether there was any afflux caused by this this design. This is the existing. This is what it looks like when you calculate it. We'd actually drawn in flow arrows across the road just to check to see what was going into the model, and what was going over the road, and what was going through the pipes. A good way of just checking to see where flow is going. You can see upstream flow is 55 cumex, across the road 40. You'd expect about 15 through the pipe. And
so this is just a results line.
Yeah, that's right.
That'll just capture the 2D.
Yeah,
what's going on there.
Exactly.
So and we've got also the graph here of the. Yeah.
Sorry, I was a bit quick there.
That's right.
I'll bring that back up. So that's the flows through the pipe. That'll come back up on the screen now, hopefully.
Yeah, sorry about for the delay, guys. It's literally GoToWebinar. It's not much we can do about it.
Yeah.
There you go.
There you go. It's up.
Pretty graph.
Pretty graph. And I just really quickly checked because it seemed low for two 1650 pipes. So just before, about half an hour ago, I pulled up the nomographs from TMR, had a look to see where the 1650 would come through with a 1 meter head. And sure enough, about 8 cumex per pipe, and that's what's showing up here. So checks out. I didn't check it before I came in. That's embarrassing, but hey, it worked.
Always sanity check your models.
Yeah, validation. We just do a heap of that. So after you run a model, it may look, you got a result. We always check it to see whether things are right. And the next job I'll go to really quickly. We're running out of time, but I'll show you where that comes in handy. One last thing. One way of modelling your large crossroad culverts. I'll just quickly touch on that. You can see here I've used quite large interface lines. Now, when we didn't have interface lines, XP was bombing out, come out with a 2D unstable. It's really a protection tool. When you first start modelling, you think, these errors, they're killing me. but it means that there's an instability in the model. What's probably happening is because, just to give you an idea of how it works, if those pipes, that one line is outflowing, is connecting through two 1650 pipes, it's trying to push through the flow into a grid of 1 metre by 1 metre. That's going to cause an instability. So that's why you have these interface lines. It's worked in the past when we haven't had an interface line, but it pushes, it connects through the 2D water level with the 1D line, and you can actually see if I run a long section, it does connect through with how you'd expect it to look. I'm just trying to close this over here. That's okay. I'll zoom in. Well, that doesn't look good. Let's try that again. Yeah, something's not quite right there. Let's flip the pipe. Worked before, don't know why it's not working now. But you'll see the HDL usually, and the HDL actually mirrored the...
Oh, you set all your ground elevations from 10 before.
I changed the pipe. That's
you changed
right.
Everything.
I stuffed it up. So you'll see the HDL before I stuffed it up. It was about 1 metre higher on the upstream to the lower side, and it was over the road. So you could see that the 1D is connecting through the 2D properly, and that's all part of your validation. So that's
very good.
Actually, last thing. This is what councillors love or managers love.
Yeah. So when your boss is coming up around his shoulder, just quickly hit this button and hit play and sit back and drink your coffee
and watch the flood. Alt tab out of news.com.
Yeah.
Play this.
It's just catching up.
I completely don't do that, by the way. If Pete's watching.
So you can sort of see, animations. This will be recorded if you want to watch the full recording later with better quality. By all means, that'll be uploaded onto the website and you can watch that.
There you go. I'll stop it there. It gets better, as in less flooding. Right. So back to the PowerPoint. That was what the channel looked like. So you'd think that would be okay by just raising the Reno mattress channel, filling in the scour hole. We thought so too. We just had to check it. And just really quickly, I ran this afflux by exporting the time step. So click through the water elevations. It's very important you get the water elevations because it gives you an actual Z coordinate, not just a water depth. Exporting that, I exported that to 12D, and I did a depth range polygon, and it gave me this result. Now, Ben, when I was running this past Ben, he went, "I hope this didn't take you long to do because."
Yeah, you can just jump into. Into a difference map in XP, and so you learned something new as part of this webinar. Anyway, you learned something new.
That's right.
There we go.
I believe that's under Tools and Utility Interface.
Yes. So we've got this difference map tool that will just take two differences. To two 2D maps and then just tell you the differences in them in a separate map.
Yeah.
So it's all just done inside the software as well.
There you go.
But you can, I guess that's a good demonstration of how easy it is. XP is really, we're really passionate about making sure your data can come in and out of the software. We're not trying to hold you into a particular proprietary format. We want to be able to use other tools with it. So we export, import nearly anything. If you've got a problem with that, with what you can bring in, you can always convert the data. It's quite easy to do.
Yeah, that's right.
So yeah, we're generally pretty open with our standards of data.
Yeah. So that's an afflux for a 100-year event, and we're comfortable because there was nothing more than mostly about zero within private property.
Yeah.
And there was actually, it showed a slight lowering through most of it. So there. I'll have to really zoom through a lot of these. How much longer? About 5 minutes?
I reckon you can go through this one just quickly, and then we'll have some time at the end for questions.
Yeah.
But by all means, have a long lunch, guys, if you're keen to learn some more.
Okay, I'll try and go for about 5-10 minutes more. This project, if you look at QDMs, the reason we used XP for Van Diemen was because it was one of those catchments that rational methods shouldn't be used for. And you can kind of see it here, a big built-up urban catchment with a huge steep escarpment of heavy vegetation and rocks, boulders, down into the project catchment, which we're trying to to solve inundation for through trap sags. There's a photo just at the base of that escarpment. So the rational method design told us about 6.7 cumex, I think, was coming down to this point. You couldn't really imagine that, really, and that's probably because it wasn't actually going all in there. Kai's dropped his keys by the look of it. Now, the way we kind of approached this project, I don't have the model to alt-tab between, but the original, there was a design done using rational method completely before we went and had a look back through it, because it was way over budget at 3 mil, about 1.2 million more than budget. The flows coming down to that big escarpment were via this road. So the roundabout, and if you were to eyeball and make an assumption of where the flows are going, I would have said, yeah, I'd say most of the flows except for that, the lane going against you, all that was going down into the sag. But in reality, when it was modelled, you can see that a lot of it, just because of the slope of the road coming towards the roundabout, it was the velocity was momentum was drawing it through the roundabout. There was still some going through into the sag to the south of that photo image, but a lot was lost, and about a QMAC was lost through there. So that's a QMAC less to design for. Yeah. One last point I'll make when looking at this is that you can see how speckly that the water surface is. That's because there's no detailed survey. Highly recommend detailed survey of at least the curb, center line, maybe some of the verge, just to get laminar flow along the road. Very important here. So this is the sag. The far end of that photo, there's a super elevated road, so you'd think that it's fairly well defined, the water would go around that curve, but in reality it actually shot off. It kind of, the water super elevated off, and right at that bend, it was the difference between going into the catchment and leaving the catchment. About another 400 litres a second was saved from the model, from going into the model there. Yeah, so the lessons learned for that one was try and use a small grid size. Another little point is we had trouble trying to get a 1 metre grid size running using the whole 1:1.5, so your time step of about 1 second, grid size of 1.5. We had to go down to a 0.4 second time step for a 1 metre grid. Mm-hmm. Next project, I actually do have the model here, so I'll quickly show you. It's got a detention basin in there. That's the catchment. You can see this playing field in the middle. This is quite difficult to try and model in by hand, so XP was great to try and see what was actually coming into this field inlet, model in some orifice flows, and see where water was bypassing. So I've got two different design options, and you can flick between the two. I'm just waiting for the screen to catch up. That was, the previous one was just the a small retaining wall. Now I've flicked down to an impervious retaining wall. We just had a look at to see if we could put one in, and you can just flick between the two and just see the difference it makes. And that's where the option, just running different options of design to make your mind up what you want to do, is quite powerful with XP. The biggest game we had here was just modelling in a 12D tin that we designed for an overland flow channel, where we've cleaned it out, deepened it, lined it with Reno mattress. That's a photo looking up towards the culverts where the flow is coming out, and downstream where it's all clogs. And this is we could model the existing scenario and see what we had to try and capture to try and work out what size channel. So that's existing and design, and really good way of working out what size of channel to give to a designer to do the detailed design for. And just for your information, we had about 13 QMEX through. That's what was calced out if we had rational. We actually had, as a matter of fact, 10.8, so about a 2 QMEC drop just from modelling a detention basin. So it really just brings you back down to what is actually happening in the real world, rather than just using an estimating, a rational method being an estimate of flow. This was rainfall on grid. We think it's a lot more accurate way of modelling at least detention basins.
Okay, so do you just want to quickly open up the last model you got there?
Yeah,
and
sure.
Do a bit of a showcase of that, just to sort of see. So you've been doing quite a bit in it, it looks like.
Yeah, absolutely. Here we go. Got a few models open. So this is Mayflower. This is the one we just looked at. This is the detention basin. So
that's modelled in 1D, 2D?
The detention basin is modelled in 2D.
Yep.
So we've just got the existing pipe network through with the nodes modelled in with the inflow capture, but we've actually worked out the actual coefficient and exponent of that based on grid the grate size, blockage factor, and the orifice really. So each one of those changes, they're little tiny field inlets.
Mm-hmm.
The big one down here, you're going to expect a bigger coefficient, and there you go. And it was accurate, and we've just hand calced it and checked those flows spot on.
Yeah, okay. Good. I think we'll jump into some, so yeah, we've seen that last model. I think we'll, just because we're running short on time, jump into a couple of questions that have come through. There's actually one here that I'm actually interested to hear the answer of. So Logan City Council's, obviously heard of AR&R 2016. What has Logan been doing to implement AR&R 2016, or what are your plans for that or around that?
Well, yeah, you've dropped that one on me. We haven't actually been, we rely a lot on QDM for our direction on how to model urban stormwater. I believe that QDM may be upgraded, new revision shortly. So we haven't done a lot of AR&R changes based on AR&R, but we've heard rumours that rational method will be wound right back in regards to the scale of what you can use it for. So we're using Rainfall and Grid, which is, I guess, recommended in AR&R, and we have plans to. Some of the designers have started using it for some of their projects to verify their flows. Yeah. So we know that it's coming. We know it's coming.
Yeah, they certainly got a lot more guidance about using Rainfall on-grid models. So what you've seen today, Liam, you've obviously been on our training course.
Yeah.
Yeah. So you've had formal training in the software. So if anything's going a bit above your head in the presentation, we run formal training sessions in this, and we actually have a couple coming up in the new year. So do check our website if you are interested in any of that. Thanks everyone for joining. Thank you all for your support in 2017. We've had a record year for webinars, attendance and interest. We are open to any ideas or feedback from the webinars, so please let us know. But thanks again for your support in 2016. We'll see you all in 2017. Thanks very much.
Bye.